Okay, Assalamualaikum and good morning. So for today we will begin with the new topics in this course, which is on programmable logic control. So this is the introduction to programmable logic control. Then this is lesson number 19. By the end of this lecture, students should be able to explain the function, symbol, and components of programmable logic controller or PLC. Okay, so there are few types of components in PLC that we will look later on. Alright, so before that, what is PLC? Okay, basically it's an industrial computer in which the hardware and software has been specifically adapted to industrial environment. So basically PLC is the computer, okay, that being used in industry. So means that when it's being used in industry, we can say that the system that we use or the computer that being used is very robust and because the system need to run continuously, okay, sometimes subjected to the power disruption and so on. So means that this kind of computer has been designed specifically for the industrial environment. Right, so comparison between traditional relay logic and PLC logic. Okay, traditional relay logic refers to the system that we learn in electro hydraulics and also pneumatics. Okay, so we use a relay system to control the circuit in electro hydraulics and pneumatics. So the first difference here, okay, is the relay system, okay, or electro hydraulic or electro pneumatic system, large complicated system that take a lot of space. Okay, so it's use quite huge space. Okay, so it need to have a specific control box and also a lot of wiring to accommodate. Then for PLC, okay, one PLC can control a large system, take up less floor space than relay-based system, right? So PLC is basically has been adapted or has been designed to adapt the industrial environment so that it has been designed as compact as possible. The second one, hardwired device used to configure relay ladder. So we use the hardwire or the wiring system, okay, to configure the relay ladder. Then for PLC, only the input and output devices are hardwired. The inner working of PLC are solid state. Okay, so as I show in one of the video in hydraulic lab, so in order to connect one relay or one component with another component, so a lot of wiring need to be set up. But for PLC system, we only need to make the wiring from input and also the output component. Means that from the input to PLC, okay, then from PLC to the output. Okay, that's the only the wiring that required. Then for the relay system, it's difficult to modify or update programs. So once we set up the wiring, so if we want to update the program, we need to change the wiring. Okay, but with PLC, so we use the computer program, okay, or PLC programming. So if we want to update or modify the program, we just need to change the program and download to the PLC. Then for the relay, it has a limited mechanical life. PLC is a solid state device, has a very long life and require little maintenance. Okay. Then finally requires to separate hardwired timers and counters. If we want to use the timers and also counters for our circuit, so we need to have a specific component or specific part for the timers and counters. But for PLC, the counters and timers are the internal function that we only can call inside the program. Okay, so we do not need to have an additional component for it. Right, so this is the components of PLC. Okay, if we look here, it's roughly the same with a computer. Okay, number one, we have a CPU, then we have memory, programming device, okay, power supply, the input, and also the output. Right, so if we look detail into the function of each component here, number one is CPU, okay, central processing unit, contain one or more microprocessors, is a brain for PLC. Okay, it is basically same type of microprocessor in microcomputer, except PLC microprocessor accommodate ladder logic instead of other language. So CPU here is the function is roughly the same with CPU in a computer. Okay, but it's only able or the PLC only capable to accommodate or to read the ladder logic instead of other languages. So in the PC, normally we will use either Windows, okay, or Mac, alright, and so on. But in PLC, okay, the language that we use is ladder logic. So in order to program the system, we need to establish or write the ladder diagram or ladder logic. And then the function for CPU is to execute the task, manage memory, then monitor input, evaluate logic, and turn on appropriate output. Okay, so this is the control system for PLC. Then the memory, okay, as in computer also, it consists of ROM and also RAM. So ROM is read-only memory. Okay, the operating system is burned into ROM by manufacturer. Contain OS control function. Okay, the software, if in PC we have Windows, so in ROM here is the place where we burn the OS for PLC. Okay, so non-violate memory, when the electricity shut off, this memory is retained. User cannot change the ROM. So this is the permanent memory. Okay, even though when electricity is being turned off. So basically in PLC, okay, beside the power supply from outside, okay, so inside here it also have the internal memory, which is from the batteries that being used. So means that if the external supply is being cut off, okay, so the memory will remain as long as the battery is still operated. Okay, but once battery is not functioning, okay, the data that being written in RAM, okay, we will look later on, will be erased, but the data in the ROM will remain in the memory. Right, so RAM is a user memory. Okay, user can read or write program to RAM. So violate when electricity shut off and the data in memory loss. Use battery to avoid memory loss. Okay, so as I mentioned, okay, in PLC they have an external power supply and also the battery. Okay, but as long as the battery here is functioning, the memory inside the RAM will remain. Okay, but once the battery is not functioning, okay, all the data in RAM will be erased. Okay, but the data inside the ROM will maintain. Okay, So means that the RAM is the place where we download the program. So normally we write a program in the computer, and then we download the program to the PLC. Okay, so we download that program into the RAM. Okay, so means that our program will still remain if the battery is still in use. But if battery is not functioning, so the data or the program that we write also will be erased. Then for programming device, okay, device that are used to write the program, troubleshoot the PLC. Okay, so this is the way how we can program the PLC. We can use a computer or handheld programmer and microcomputers. Okay, so for current technology, I think we can use the mobile phone to uh, program the PLC as well. Okay. Then the power supply, okay, to supply power for CPU, most PLC operated on 115 volt at AC. Okay, because for PLC, basically there are a lot of different manufacturer, but most of it is coming from Europe or US. Okay, so that's why the voltage is 115 volt. Then the input section perform two tasks, taking input from outside world and protecting CPU from outside world. Okay, so this is the input section. Okay, so it's convert real world logic to required logic level by CPU. So input device, the example here are switches, sensors, and etc. Okay, so the function take input from outside, then and also protecting CPU from outside world. So means that the input section also must be capable to detect is there any unusual power or unusual voltage supply to the PLC. So if there is an unusual voltage being supplied, so they will cut off the power at the input side. Okay, so it will protect CPU from being damaged. Then the output section provide connection to real world output. Okay, so we have a PLC here. Then we have the input. Okay, give the inputs, for example, sensor and so on. Then we have the output side. Right, so the output here can be motor starter, light, coil, valve, and etc. So the normal output is a motor, but most in our application, most of the time we will use the coil, right, or the solenoid. Okay, so if you still remember for electro-hydraulics and pneumatics, so we have solenoid on the valve. So these solenoids are also the output. Okay. Alright, so now we move to fundamental of PLC programming. Okay, so as being mentioned, the program for PLC is called as a ladder logic or ladder diagram. Basically, it's symbolic representation of electrical circuit. Okay, symbol in ladder logic is divided into contact or input and also coil or the output. Right, so this is an example of ladder logic. Okay, so we have the input side here, and this side are the output. Right, so for the input side, okay, most of it we can see that is in contact symbol, and for the output mostly in term of the coil. Okay, so the name ladder logic is coming from the shape of this diagram, which like the ladders. Okay, it has a steps here or rung here like the ladder. Right, so the contact, right, so most input to PLC are either true or false. Okay, input sensors and switches, so common symbol that we use. So as we mentioned, the input for PLC are sensors and also switches as in a previous section, this one. Okay, input and sensors. Alright, so the common symbol that being used is this one, normally open type and normally closed. Okay, if you still remember in electro hydraulic and pneumatics, so the normally open symbol is like this and normally closed symbol is like this. Okay, but in PLC the normally open is this one and normally closed is this one. So means that from this diagram we already know if we supply the voltage, so it being stopped here, okay, before it being actuated. But for this normally closed, if we supply the voltage, so the voltage can flow to the next side. Okay, so that is the normally closed type. Okay, then the coil. Okay, coil are output symbol. So the majority of the input that we use are from the coil. Okay, the real output device can be motor, light, pump, counter, timer, relay, and so on. Okay, but in the ladder diagram, we will use the symbol of the coil. Okay, so coil symbol, okay, this one. Right, so in electro hydraulic or electro pneumatic, the symbol of the coil is like this. Okay, normally we will put label K1, for example. Okay, but in PLC, we use this symbol. Or sometimes we also use a circle symbol. Okay, so it's bring the same meaning, which is the output, meaning that this is the output. Okay, this is also the output symbol. Okay, then the ladder diagram design. Okay, draw a ladder diagram for a bell circuit. When a switch is pressed, the bell will ring. So now we have the input, so the switch is the input, and the output is the bell. Okay, so this is the circuit. So we have the input switch and the output bell. Okay, so means that if we connect this switch, so we will have the output. Okay, so means right now we turn on the switch, so the bell also will deliver the output, or the bell will ring. Then modify the diagram so that when the switch is pressed once and released, the bell is ringing continuously. Okay, so so means that here we need to give the continuous output. So if you still remember, for this purpose we need to use the memory circuit. Okay, so we have the switch, we have the output, the bell, and we put one latch here, LATCH, or the memory circuit. Right, so this one is called as latch of bell. So this is we have the output of bell, okay, the coil of bell, then that one is being turned into the input or the contact. Okay, so means that when we press the switch, bell will ringing, or bell output will turn on, so that the bell contact also will be connected. So the output will continuously on, or the bell will continuously ring. Add another button to stop bell ringing. Okay, so in this circuit there is no off contact or off button, right? So here we add one stop contact. Okay, so when the bell is continuously ringing and we actuate the stop button or stop contact here, right? So the line will be disconnected. So now this line, since the stop button is on, so the line is being disconnected. Okay, so the bell will stop ringing. Okay, so that is some of the fundamental in the design of a programmable logic control. A drill press, this is an exercise. A drill press machine only works if there is a part present and the operator has one hand on each start switch. We have two start switch. Okay, so this is the circuit. Okay, we have two switch that been connected in series. Okay, which means that the connection of switch 1 and switch 2 here are the AND connection. Means both of the switch must be pushed or must be actuated in order to have the output for the drilling. Okay, so if we just press switch 1, there is no output. Okay, we must press or we must actuate both contact to have the output at the drilling process. Okay, right, so that is the introduction part of the PLC. Okay, but we need to bear in mind that for the circuit here, we cannot manually actuate the switch. Okay, so the switch is being controlled by a different contact. So later on when we conduct simulation, we will look into detail that we cannot control the circuit or cannot actuate the switch from the ladder diagram. We must control from electrical diagram instead of from ladder diagram. Okay, so that's all for this lesson. Thank you.